So if you've just joined us, we're getting ready to kick off the first SedMIP webinar. This is a new OCB small group activity that will take place over the next 1 to 2 years. I'm going to let Samantha take it away with her slide presentation to introduce what SedMIP is and what its aims are and how you can get involved.
Thank you so much, Heather. Yeah, excited to be here. Excited to see so much interest and folks joining us in this webinar series. I am Samantha Siedlecki. I'm an associate professor at the University of Connecticut, and I'm joined by several members of our steering committee here today, some of which who will also be helping present various aspects. You can see the full list of them there. And the full pictures of them as well, like, on this list. You can find out more about this and continue to get involved at our website. And so, let's start in and dig into what actually is SedMIP. What are we looking to do? So the goal today is to introduce the webinar, introduce the initiative to everyone, this new funded activity. We are really looking to gather community input and build on the momentum from the benthic ecosystem carbon synthesis group, which the BECS group, which I'll talk more about if you don't know about that as well, and build more cross-disciplinary connections and outline the next steps toward a formal experimental protocol for a model intercomparison project, or a MIP. And so really we're looking to share what we've learned from hearing from you already through some of the surveys and town halls that we've done, but also opening the floor up for discussion and hearing from you here. So our plan is to start off with a brief overview of kind of why we think we need a MIP and what we're thinking about for it. We're going to hear from Colleen Petrik, who's going to tell us about another MIP that has already happened or is ongoing as well, called Fish MIP. And so we'll hear about, some experiences there. We'll then kind of move, Jessica will kind of talk about the community input that we've had this far from both the town hall at Ocean Sciences recently, as well as a survey that went around. And then we'll open up the floor for Q&A and discussion. And of course, we'll end with how you can continue to be involved, which we'd like you to be. So just kind of a video to start us off. This video is from Mbari, as you can see here. It's actually the seafloor at 4,000 meters at Station M. And the video starts off with like some organisms on the seafloor moving around. But you can see this like darkness that will fall like right around now, that you start to see the flux of organic carbon kind of delivered to the seafloor. And then this, the scurry of almost like Roomba-like activity to kind of quickly sweep it up. And, this is really like an inspirational video for someone who thinks about, actually simulating this environment. Obviously there's a lot going on here. The benthic processes that are happening associated with this are important for ocean chemistry, carbon sequestration, climate feedbacks, and benthic biodiversity. So BECS was this benthic ecosystem and carbon synthesis group, which you can find out more about on their website, as well as a recent publication led by Christina Schultz, kind of overview you can see with this QR code there. So this is one figure from that paper talking about how we kind of envisioned everything kind of fitting together. What the community came together as part of BECS and sort of saw what was needed to kind of move forward. And so we are here at the mechanistic model development kind of side of things, where we really need to interact across all these scales with various aspects of the various aspects of the observations and the data. But we really wanted to, as part of this group, we discussed how a MIP could actually help us. And so that the conversation started as a part of BECS and discussion of the model development side. And currently, I don't know if we can get rid of that symbol that's there. Heather, if there's some way that you can help, that would be wonderful. So there's not a lot of modeling tools that exist that can address some of the emerging community needs. Here's an example of a modeling study that was built to include this kind of complex environment in the benthos, including the biota and the organic carbon and the flux, in order to look at the impact of trawling, right, of fishing on the bottom. And so that's obviously one that's come up, and now there's not a lot of tools out there in order to address this. MCDR is another one, right, that kind of has come up in our conversations. And, a lot of the models that exist don't have this complicated representation. Instead, they have more what we call a reflective condition, which is pictured in this pixely image on the top, which there's a sharper one of in a following slide, where you see the delivery of organic material to the seafloor, and then most of it is just, respired and returned, commonly referred to as a reflective boundary condition in the biogeochemistry. And maybe you have some basic bioturbation kind of going on, but nothing as complicated as what you'd want to ask questions that are emerging in the community. So the problem is that there's a lot of, I'm moving my little Zoom bar over here. There's a lot of challenges that models face to kind of do this well, right? One is that there's a lot of variability within the models themselves and uncertainty that results because of that. So the models differ in their assumptions, the structure, the complexity, like why they were created. There's not really a standardized group of benchmarks to kind of evaluate their success. The observational constraints are sparse, and there's difficulty integrating this scale into Earth system models. So kind of going from that really fine, high resolution, image of top A from the Bianchi paper, bioturbation, thinking about those small scales all the way up to a broad kind of climate scale of like the shelf, right? Most processes that are happening are assumed to be one-dimensional, and all of this contributes to structural uncertainty and predictions about carbon. So structural uncertainty is one aspect of uncertainty that includes things like forcing uncertainty, parameter uncertainty, structural uncertainty sometimes just means unknown mathematical formulations that we don't actually know how to approximate a process. And then some numerical uncertainty as well, like where the approximations aren't exact, right? And this idea was born out of the global climate community. So the most famous example from the Hawkins and Sutton paper from 2009, thinking about global average temperature and sort of how to convey when we were confident enough to make a decision, right, as a global society around emissions. So on the left, you see projected global temperature over time from the 60s to 2100, so out into the future. And, all of the wiggles represent the individual ensemble members contributing to those future predictions at various emissions scenarios that are colored. So blue being the lowest emissions and red being the highest emissions there. And so on the right, you can see that this paper worked towards separating out the uncertainty from the total uncertainty in the black to that set from the scenario, which is, depending on the emission scenario in this case. And then the model uncertainty is in blue, which is also the structural uncertainty that were referred to from the previous slide, or the internal variability, which would be something like natural variability in the system. So this idea has been around in the kind of climate space and in which inspired, of course, SedMIP, the Model Intercomparison project, the global Model Intercomparison project. So the parameter uncertainty and unknown mathematical formulations we think are best addressed with a MIP, which is part of why, and we think that these two areas, we suspect these two areas as being ones where the community could get together and make some forward progress thinking about them. So with that, I will pass off the slides to Professor Colleen Petrik from Scripps Institute of Oceanography. And just tell me when you want me to go next, and I'm happy to hit next for you, Colleen. Yeah.
Thanks, Sam. Go ahead. So I am a co-coordinator of the Fisheries and Marine Ecosystem Model Intercomparison Project. We are what is called an impact MIP, which means we are an ensemble of models that are not running climate scenarios ourselves. That are used in SedMIP. We instead use the output of those climate, ocean, Earth system models to then see what the impacts would be for something else. And in our case, it's fish and other higher trophic levels in the ocean. So this schematic kind of shows how we operate. At the very top, we get climate change scenarios, these projections, and we usually operate under you choosing like the highest emissions and the lowest emissions scenario to look at the range of future uncertainty with those scenarios. We then use two different Earth system models to get Earth system model uncertainty. So currently there's one from GFDL and one from IPSL. Those are the models that have the variables that we need to force our fish and marine ecosystem models. And then we use those outputs as input forcing in these models. We run our models with under these climate change scenarios and then get results. The models depicted at the bottom, we have about 9 that are global models and then over 60 regional models. These have huge amounts of structural and parameter uncertainty. So very different structures about how they represent fish, whether it's by size or type or actual species, and how they represent fluxes of biomass and energy. And so we kind of embrace this uncertainty because there's a lot of power in ensembles. I don't know if you've ever like heard these anecdotal stories about like if you ask 1,000 people how much a cow weighs, like the mean is pretty close to the actual weight of that cow. So the mean of the ensemble is a pretty good prediction of the future, whereas the uncertainty helps tell you the range that we just don't know about. It could be higher, it could be lower. Of course, there's also some drawbacks to that uncertainty, and that's if you can't distinguish, for instance, these two emission scenarios. If the uncertainty overlaps between them, then there's really no information you can provide the community about whether low emission scenario is actually going to be beneficial for the ocean compared to high emission scenarios. Next slide, please. So how did we go about forming this model intercomparison project? I wasn't really there for that process, but we have a protocol paper that kind of describes it. So starting all the way on the left, there is this table with the initial models that were part of the MIP and listing what are the variables they need to force the model. And so you can see the dots when they use it or blank spaces when they don't. And so trying to come up with the common set of forcing that is needed, then knowing what variables you need, you go and look for Earth system models that have those variables available for your historic and future scenarios. And then finally, when you run these models, you have to figure out what are the output variables you're going to compare. So this final table on the right is showing the different state variables or fluxes or rates simulated in those models that could be saved as outputs for comparison. Next slide, please. And this is just an example of one of those metrics we decided to compare. It's called total consumer carbon biomass. This includes anything that is basically not autotrophs, because some models do represent zooplankton or benthic invertebrates, where others are just fish. And you can see 3 examples on the right and the model average. Next slide. And so here are some examples of the different experiments and simulations that we have run with FishMIP. So we have done 2 rounds of climate change projections with SedMIP 5 and SedMIP 6. The SedMIP 5 rounds are the dots, and the SedMIP 6 are the lines. And what happened when SedMIP 6, the uncertainty envelopes are for SedMIP 6. And this time we could actually get a separation of those two scenarios and see that there is a benefit to following a lower emissions pathway. So that was really fantastic to see. Another thing that we do is exemplified in the middle is like, it's not just important to understand the mean, but understand how variable the model results can be with standard deviation. That's also kind of telling you the uncertainty, but also how much they agree. So just because the mean or the uncertainty bounds are going negative doesn't mean that all the biomass change is negative. Some might say there's a positive increase in biomass. So understanding which regions have kind of more strength in their agreement can help add weight to those ensemble projections. Another thing we've done is perform sensitivity experiments to isolate the impact of individual drivers. On the top right, there is the change in total consumer biomass if just having warming, but no changes in productivity. And the bottom is the converse. So there's no warming, but just changes in ocean productivity. And you can see how the biomass changes with those two different drivers. Next slide. A lot of MIPS actually start with benchmarking, and ours did not because there was not a global data set of fish biomass for us to compare against. There are now pretty good global estimates of fish catch over time that we are using for benchmarking and assessment. Of course, that needed some modeling groups to figure out how to go about having historical fishing simulated in their models. And so for that, we needed historical estimates of effort spatially and temporally distributed in time. So the models get forced with historic effort, they simulate catch, and then we compare the simulated catch to observed catch. So this is just an example of the framework. This is using fully coupled Earth system model simulations, but our true assessment round is going to use a hindcast. But this is an example of the different ways that you can assess the model. So all the way on the left, you can just look at global mean time series. In the middle, you can consider more skill metrics that are represented in a Taylor diagram, like not just the correlation of the time series, but their standard deviations and root mean squared error. And then you can break it down into regional skill assessments. So here's correlation of those catch time series in each large marine ecosystem. Next slide. Oh, that's it. So we have the other, thing about FishMIP. It is an impact MIP that is hosted under the umbrella of EasyMIP, is that anyone can join at any time to contribute their model simulations as long as they follow our protocol. And then the model simulations are hosted on a server by EasyMIP for others to analyze if they have an interesting idea about what you could examine with an ensemble of fish and marine ecosystem models. So we have a number of working groups doing things like that. I'll pass it back to Sam.
Great. Thank you so much, Colleen. Yeah. So in our discussions of early, thinking about like what we might need, we kind of assessed a little bit about states of the models, and this was by no means exhaustive. It was just a small glance at models that were out there, and something more exhaustive is something we would like to do during this first year. But we came up with just a way of thinking about these, which is depicted here. So on the top, you see potential complexity levels broken up into 3 bins, kind of categorized by biogeochemistry. So on the top, you have maybe a low complexity, a medium complexity in the middle, and a high complexity on the right. There's also some degree of coupling with ecosystem, a benthic ecosystem. And so maybe the low complexity ecosystem is simply having a bioturbation. Maybe in the middle, you have like maybe one or two species that are inhabiting the benthos, and then maybe a full, dynamic ecosystem on the far right. So you could have a medium BGC and a high ecosystem, so kind of a low or a low medium classification system for the various model complexities. But in our initial glance, there were definitely differences in carbon cycling, the burial processes, redox processes, all of which could contribute to model structure and complexity differences, right? Most of the models were created to address a particular issue that is not necessarily thinking about the residence time of surface carbon in the benthos, right? Current sediment models, they vary in the complexity, the assumptions. There's not a lot of consensus, and this could potentially be limiting our prediction capabilities. So SedMIP was born. It's inspired by existing model intercomparison projects, or MIPs. And we are looking to improve model consensus and skill via systematic evaluation and benchmarking, quantifying benthic carbon cycle uncertainties in particular, which you've heard about now a bit from FishMIP, how way they were thinking about it. This would be available then to guide simulations that were looking to support resource management, geoengineering, as well as other needs. And we would also be able to build a community practice around this activity, and encourage others to with co-authorship to participate in this. Our objectives are to create a standardized diagnostics and data sets, to provide a mechanism to support cross-disciplinary collaboration and community building, and to identify key parameterizations and structural uncertainty in the current models as they are. So our motivating questions are kind of how much structural variability and uncertainty exists across the current suite of models, and is model skill related to that structure? And our biases that exist systemic across environments. Is there a difference between coastal, applications versus deep? How do the model assumptions influence predictions of residence time of total organic carbon? And what is needed to kind of better constrain benthic carbon cycling, so that we can work with our observational colleagues? We're thinking, given the complex, different scales that the models currently operate on, we thought about 3 complementary experimental scales to start with. FishMIP had a regional and a global. We're also suggesting a 1D kind of event scale to kind of correspond to that smallest resolution, and then so I have a regional and a global, similar to how FishMIP was just described. And the phases, there could be phases within each one of these of experiments that could include evaluation and performance in reproducing patterns that is either spatial, temporal patterns, or maybe budgets, right, within various domains, the 3 here. There could also be a phase that explores future scenarios and feedbacks with climate, so kind of long time scales. And then there could be a shorter time scale, kind of more event scale response that was thinking more about MCDR, kind of a time scale. So this is, we need input from you. We're really seeking to foster community involvement. We're looking for input on protocol design and model inventory, recommendations for benchmark priorities, and feedback on the observational data sets and diagnostics we will plan to use for model evaluation. With that in mind, there's a parallel data synthesis effort that also is a part of BECS that is working on identifying historical data gaps and data sets in order to fill gaps. They are also working on, providing or figuring out consistent standards and data templates for metadata across those large historical data sets. And if you're interested and want to learn more about that, you should contact Christina Schultz, who's on our steering committee and on this call right now. There's her email. And then there's a SCORE proposal that's also under review right now, kind of to form a working group to further continue that. And you can contact Nick Ray about that as well. So that's on the observational side. But we're also going to ask you to participate in surveys as part of the SedMIP community, additional webinars, which we'll talk about more in a minute, and town halls at various meetings. And we really look forward to seeing you there. And with that, I'll pass it off to steering committee member Jessica Liu from GFDF.
All right. So this is an interactive webinar. So what I would like you guys to do is either do this on your phone or on your computer. With the phone, it would be to go to this QR code. On your computer would be go to slido.com and put in this code for participation. And we have two questions. The first is what barriers do you see for model intercomparison? And this kind of allows you to select multiple barriers or multiple answers. And yeah, as people respond, you'll see this, you'll see in real time what folks are thinking. I'm seeing a lot of agreement on varying model complexity, different state variables that are tracked, different forcings being a major barrier for intercomparison, as well as comparing just fundamentally similar models. Yeah, comparing apples to oranges, for example, and different scales. All right, we'll wait another minute or so for people to, for last responses or so to chime in before going to our next question. Yeah, let's move to our next question. All right, what opportunities do you see for model intercomparison? And again, you can select multiple choices. Sam, is it showing what the results are?
No, I don't see it changing.
Oh. Let me see if I can.
And also with the last question, I could see the results on my Slido website, and I don't even see that now.
Okay. Oh, wait, we see it here on the side. Yeah, I don't know. Oh, here we go.
There it is.
Okay. Yeah, so a lot of people agree. There's great potential for advancing the sediment modeling field, particularly in process representation and development of standard practices, coupling to global models, and to a lesser degree, reducing uncertainty and building community. Awesome. Okay. All right. And I'll tell you what we heard at the when we had a town hall at Ocean Sciences this past February. It was about 50 participants. We asked a number of questions in kind of a small group discussion format about gaps in modeling, observational data sets, how to design a MIP activity, what experiments would you like to see included, and how can these communities better interact with each other? So Sam, if you can go to the next slide. There was a lot of different comments, but there were three themes that came out. The first is on key process gaps. Current models underrepresent key processes and struggle to scale realistically across space and time, especially with respect to bioturbation, carbon cycling, sediment transport. There is a strong need for tighter integration between observations and models, and this integration needs to be started early and sustained. And there has to be this structure for collaboration. Fortunately, we are building off of the efforts from the BEX working groups, so there is already a number of folks who have been, entrained in this effort from the beginning on both the observational and modeling side. And then the third was designing a flexible MIP focused on carbon and model complexity comparisons. And folks said that, having something that is flexible but well structured is kind of the unicorn needed to compare diverse models without oversimplifying. So yeah, because this would be like the unicorn, the gold standard. We really do need help figuring out what that MIP would look like. All right, next. In addition, on our website, if you go to this QR code, it just points you to your website. There's two forms. There's a form, just kind of a general interest and a sign up for giving a talk. And then the second is the community survey. So this has been live for a while, and you can still fill it out. And so far we've gotten 45 responses. And the survey goals are to, help prioritize MIP activities and begin developing a model inventory. So Sam, next. What I would like you guys to get from this is that, most everyone who responded did not have any MIP experience. So if you feel a little out of your depth here, then that's okay. Like 80% folks have no experience, but most folks do have some modeling experience. There's a wide distribution of experience levels from student all the way to, senior scientist who express interest in this activity. And then next. The survey really indicated that building community is a top reason for participation here. So that's really great to hear. And then I think we have one more slide. Yeah, and the priorities that the respondents gave were establishing benchmarks to both compare and constrain models, setting up standardized forcing scenarios, and to test model responses, and then quantifying and identifying processes key to the sediment. So we've started this. One of our first goals for the first year is establishing a model inventory. So far, the survey has, out of the survey, we've identified 15 models. But most models actually only have a single user or a small user group. So with that, we're kind of, and this is very consistent with our survey that we did as part of the Siedlecki et al. Publication that is currently in review in oceanography, is that there's a large diversity of models. And models tend to be developed for a single purpose or for, just a couple papers. And so it has a small user base. This really underwrites the need for, the community, more community to gather together, and more intercomparison. Leaves us a lot of room for, identifying differences between the models, really getting at that structural uncertainty component that Sam was talking about earlier. So I think this might be the end of my, oh, okay. Sorry. We have a webinar series that's coming up starting in end of May, Thursday, May 28th, 11 a.m. Eastern Time, which will be 1700 in Central European Time. We'll start off talking about a new model development effort here at the NOAA Geophysical Fluid Dynamics Laboratory called Seabed, a carbon benthic ecosystems and digenesis model. So tune in for that. I believe Heather just dropped in a link to register for that, the Zoom. And then next, at the end of June, we're still trying to pin down an exact date and time, but Olivier Sulpis is going to present on the RADI models. We're going to take a small break in July and August, and then return back in September to hear from Julia Moriarty. All right. All right, we have a number of upcoming activities, and before I open up the floor for discussion, just want to let you know roughly what our timeline is. We have these ongoing webinars and community surveys, and we were planned to have a workshop in either late fall 2027 or early 2028, potentially in line with the Ocean Sciences meeting in Vancouver. We also have plans to do some additional town halls at both at EGU and Goldschmidt, but welcome additional suggestions. We are currently building the model inventory, and then next year we will focus on developing our shared diagnostic framework. And that's roughly, and then, writing a model, like kind of a description of the SedMIP, what the protocol would be like, that paper. Okay, so with that, Sam, would you want me to do this? Just opening it up for, yeah, thank you very much. Let's open it up for discussion. We really wanted this opening webinar to be interactive for folks to bring their ideas, questions, comments, complaints.
Yeah, and Heather, can people unmute themselves, or do they need to put something in the? They
Yes.
can unmute themselves.
Yep,
Wonderful.
you could please come on camera, unmute yourself if you want to,
Yeah.
you want to talk.
Christoph.
Hi there. Nice to see you at last. So I'm glad to be here. I think somebody raised the point of the data set, where to which we could, evaluate, parameterize, and then at the end of it, use the model. There's a large need for that. And how do you envision the kind of data set that would be most useful, like in terms of regions, in terms of like transects from the coast to the open ocean? What would be the need for a proper evaluation of these models?
I think we have not settled on this yet. You know what I mean? I think this is going to be a part of the benchmark conversation. But the three kind of different spatial areas that we talked about were the experiments, I think will kind of corresponds to different data needs, right, from each one. And there are some locations that have, temporal coverage, right? That have high, moorings, like that station M1 I showed you have like more data sets, over time. So there, you could have some, time series ones at that 1D, right? And then some regional observations maybe on the shelf, right? And then a global data set need and synthesis. But I also want to invite Christina to talk about, her response to that. And I see Colleen has her hand raised as well. Yeah.
Do you want to go, Colleen? Or?
Sure. I think that Christoph raised a great point or idea here is that like as a kind of modeler myself, we often think about having these like globally gridded time series for model evaluation and doing point by point comparisons or time series comparisons. And sometimes those can be too strict or, not really identifying how well models perform. And there's a lot more power in looking for patterns and like regional contrasts. So, Christoph just mentioned the one like from the coast out to the deep ocean. Like that would be really great, I think, as a type of data set or observations for assessment and being able to think as we start developing these metrics for assessment, thinking beyond just the like point by point comparisons.
Yeah, I'd just compliment by saying that I think the first thing is just getting everything we need and just evaluating what's the spatial temporal variability for different things, right? And what can we collocate? But that's why we're trying to do both the modeling and the observational pieces side by side and have some modelers on the everything that we're doing on the observational side as well, so that we can keep this conversation going. Because I think part of it is building a broader benthic community that's brings together the different expertises, because that's been a part that's missing. And I'd love to hear any other opinions people may have.
How do we do, Christoph? Any response? Yeah.
Yeah, I like the idea of enrolling also experimenters or people that do the measurements at sea on the benthic compartment, because I think like having both modelers and experimenters together on this group would definitely bring something new, because myself, I was a modeler before, and when you're a modeler, I mean, you see things like more theoretically, but once you put your hands in the mud,
Yeah.
then so and so it's interesting that people are connected together, and I think what Christina said, and we also put that in her recent paper. That we needed to have this kind of set of data that would also help also building the model. So that should be, to me, that should really be two ways. Not only
Yeah.
the experimenters giving the data for model evaluation and so on, but also helping building the models in the complexity that you showed, Samantha, in your presentation. I mean, there's so much complexity, and also, and so basically the experimenters will come with this complexity, saying, "Oh, there's a lot of guys, walking everywhere, disturbing everything," and then the modelers will come saying, "Okay, calm down, there's only a few things we can put in our equation."
Yes.
And then, going these two ways, then we'll somehow have a range of models with different complexities. But at the end of it, that will also give a way to have a better understanding of the seafloor processes. Yeah. So yeah. So enroll more experimentals also in the group. That would be good. So.
Kelly?
Yeah, I was going to say that it might be interesting to sort of look at it from the perspective of what are the major end user groups that are interested in benthic biogeochemical models, because it seems like there are a few clusters of like use cases of like people who are interested in it for certain carbon sequestration, and like the metrics that one might want to look at for validation in that context would be different than people who are interested in it for like the role of like benthic versus pelagic production in a more of a fisheries context. And so I think there could be some interesting ways of examining what spatial and temporal scales one should be validating on for those different use cases. So like, are you more interested in whether overall production is, higher or lower in certain years, or are you more interested in getting more of an explicit number? Like those are two different ways of looking at validation that might be useful in different contexts.
Yeah, that's a great point. I would also actually say that there are very few models that actually can do both, that can do the benthic and benthic ecosystem fisheries production and the carbon sequestration component. But yeah, like figuring out a way to evaluate more of the ecosystem models as well as the carbon models, kind of in a holistic framework would be key. Any other questions? I think we had a couple discussion points that yeah, what did we miss? What would you like to see us pursue? Yeah, I'd like to say that this MIP is very different from a MIP that's primarily done by folks within the global modeling community, where most of the MIPs out there are kind of Earth system or focused on a particular element of the climate system that uses global models. They ask for a series of variables or a series of experiments that are primarily run by the modeling centers, and then submitted on these kind of these CMIP cycles. This is very different because thus far the sediment models have not been integrated into the global models. So there is a need to, kind of do this intercomparison separate from essentially CMIP. But, there might be still some room to integrate some with CMIP models. Yes.
I'm wondering which are the two models that have more than 2 users that you identified. I guess mine is one of them, Medusa. I know of 4 at least. So I think saying that sediment models are not so well integrated in our system models is not quite correct. This has been done for 30 years by now. But I think some of them have been lost on their way.
So we're bringing it back. You're saying it's vintage. It's like a vintage product.
No, it's not vintage. It's simply sediments have always been used by people who were interested in Earth system modeling, using them for the longer time scales, say millennia, 10,000 years. I'm running sediments simulations for 50,000 years. There you need sediments. It's simply, there's no way around it. But with the CMIP type models, you are not going to run simulations for more than 100 years. And then the sediments simply are not that much of an importance. You said that this is not one of those MIPs. Well, actually, the CMIP 6 participants, they have had this kind of MIPs in the very first stages. So CMIP without any number and so on. So they have done this ages ago. And
you mean one of the early CMIPs explored sediments? Is that what you're saying?
No. The type of model intercomparison with the kind that you are aiming at here.
I see.
So much more fundamental. Really try, more focusing, say, on numerics or on really standard, very simple simulations where you could more or less see almost analytically where things should go. And we actually tried, Andrew Vrischfeld, and I was one of the proponents at that time, to set up a SedMIP 25 years ago.
Oh, you did? That's cool. What happened?
Actually, the Archer paper, no one was really interested. There were perhaps 2 or 3 groups who would like to participate, because there are not so many sediment developers. There are
Yeah.
many Earth system model users who would like to have sediments in. I am a sediment model developer, and I have contributed to 4 couplings so far to the CESM, so the Community Earth System Model.
Yeah.
We are currently working with UVic, who has had a sediment model for ages, David
Yeah.
Archer's model. We have coupled it to a German model called Fesom Recom. This is very recent. I think this was published less than a year ago. So many Earth system models are interested in having sediments in their model, especially when they are trying to go to longer timescales. But developing one and then coupling it to their model, that's a different story. And well, I think that's fine. Each and every one of you is specialist in their domain, so this community part is really. I'm not surprised that this comes out very at the top of the list. It's really being aware of what exists already and what can be reused. What else? So increased awareness of existing models. I think that would also be a very important outcome.
That's a great one.
There are many more things that many people think. Okay. So what I'm wondering is, you're talking about a flexible MIP, but is a MIP that's too flexible, or that's without sufficiently well-defined focus on well-defined protocols, not doomed to fail? I'm sorry, maybe.
No, I mean, I would say no. I think that because taking inspiration, like we struggled with some of these conversations of exactly the points that you're raising, right? Like as a steering committee bit. One of the reasons that we invited Colleen to talk, right, about FishMIP was because there are these examples of these MIPs that have emerged where, the models are operating on different spatial scales, so that you can include, all the way to the coast out to the open ocean in a rigorous way that, and learn from each other, right? Like that way. And those examples, I think, are what we're kind of leaning into. I see Colleen has her hand raised. Did you want to add something to that?
Yeah, I'll just add kind of an example of flexibility. I'm not sure if this is what is meant, but I would say FishMIP has this flexibility because we have both simulations that we would like people to run, these experiments, and then we have output variables that we would like, and we provide a ranking for all of them as like, what is the core objective, core simulations, and then secondary and tertiary for both the simulations and the output variables. And that allows flexibility because of the heterogeneity and the types of models that are there. And that we also have like a global side, those are compared amongst each other in a regional version. I imagine we would have things very similar to that with SedMIP.
Yeah, well, this is the same with the Earth system models in the comparison project. You have tier 1, tier 2, and so on. So a whole classification of outcome that's wished, mandatory, and so on. So this is right. If you see flexibility from that point of view, then that's fine. Yeah. Data were mentioned before. They also would have to know which kind of data. Would those be, say, pore water profiles or whatever? Again, much will depend on the time scales that we are interested in. When we did the coupling with Fesom Recom, which is a very high resolution model, which had much higher resolution, say, in the coastal areas than any other model that I have worked before, we really ran into deep trouble. So typically the sediments that you couple to Earth system models, they represent the mixed layer. So say the top 10 centimeters in more or less good resolutions. Most limit themselves to 7 layers. We went for 20, and then we had organic matter preservation on the shelves that was simply completely unrealistic, and we had to add, well, we already had included denitrification as a redox process, which most coupled sediments models in Earth system models do not have, but this was not sufficient. So we had to go until sulfate reduction and also extend our sediment down to 50 centimeters at least. Then things become slightly arbitrary, because sulfate reduction can almost go on as long as you want. Give it a meter more and it will go on for longer. So I think this would be, we had, at the beginning there was mentioned, the setup and so on. So this would be kind of simulations that one could define to check this. The time step will be different. The time step applied. Most Earth system models run their sediments with yearly time steps. Of course, if you go for the coasts, a year is not enough. They would have to go monthly or even weekly, possible to have pulses and so on. But then again, not every sediment model can do that because of numerical limitations.
Yeah.
There is the hand raised.
It's Heather.
Oh, I was just noting that we have a question and a comment in the chat as well. I just wanted to make sure we made time to get to those.
Yeah.
Okay.
Let me read the comment. Thank you, G, for your wonderful comment. We may reach out to you to see if you might.
I was going to see, maybe he should give a webinar about, we would love to hear more about it in detail, right?
Absolutely.
To geek out about all the details. That's what we want to do. Yeah.
Yeah. Yeah.
Okay.
Yeah. Daniel Bernal, I'm sorry if I'm pronouncing your name wrong, but says, do sediment models actually consider the influence of benthic ecosystems such as seagrasses or coral reefs and try to predict their biogeochemical behavior? Not a lot of models do that.
Yeah, very few.
Yeah. Yeah. David Burdage, we have done some work. I mean, we have a minute. Would you like to unmute yourself, talk a little bit about your work, just very briefly?
Yeah, I could, but could I actually talk about something else, which is, it seems to me I found it intriguing that you found 15 models and most of them have only been used by one group, which says to me that we as modelers like that develop a specific model for a specific problem.
Yeah.
And to me, the big issue I think is going to be, how do you take these models and scale them up in a sense, or make them applicable to all the different pixels in the ocean? And I think that's the real challenge, is looking at, and I almost kind of want to say, maybe we should just spend some time deciding we're all going to use one model, which maybe is going to be impossible, but, or sort of coalesce towards that in some way. Because then you have the ability, I think, to try to couple these a little bit more easily to Earth system models. I mean, am I making sense? Am I off base?
Yeah, I mean, I think there will always be, the folks who want to develop a specific model for their specific purpose, to investigate their particular processes. But yeah, I mean, I actually do see in the community a little bit of coalescing around a few models that can be more broadly applicable. Yeah, Medusa is one of them. I think Ratty is another one. But yeah, there may be more that
Yeah, and I think that may be the issue too, to try to get the rest of us to sort of try to work with those models in our specific problems, to see if they work for what we want to do, and provide sort of an informal validation of the models. So I've been meaning to try the Ratty models. It's only so many hours in the day.
Yeah, that's a really good point. Yeah. Thanks.
I'll just say quickly about the sediment carbonate stuff. If Daniel wants to just send me an email, I can send him, or anybody wants to send me an email, I can give you the links. We published, I don't know, 3 or 4 papers on that. I don't know that they're really to the level of detail that he or others may be interested in, but at least it was our attempt to address that problem.
Great, thank you. We're 2 minutes past the hour. Sam, would you like to wrap us up?
Oh, sure. Yeah. No, just thanks to everyone. Thanks to OCB for organizing this. We're really excited about pursuing these complicated and challenging ideas with you all. And so if you haven't already signed up to hear more, please go to our website and do so. If you have, we are going to be reaching out to you, and we look forward to your responses and participation over this next few years. So thank you so much.